What you're hearing isn't some roaring space beast. It's the sound of a black hole. And not just any black hole, a supermassive black hole at the center of the Perseus galaxy cluster. I guess you could call it a space beast. It sounds eerie, right? Well, space is a vast and scary place, but it can also produce some beautiful melodies. Today, we're going to show you some of the most mind-blowing and scariest interstellar sounds, including what Earth sounds like. But wait a minute. There is no sound in space, so where does this cosmic music come from? Alright, let's clear something up. The thing about sound is, sound waves need matter to carry the vibrations, but space is a vacuum. If you scream in space, no one hears you, remember? And that's not because you're far away, but because there's just nothing in space to vibrate and carry the sound. So, how do we get a melody like this? Well, this epic space track is the sound of a dying star, specifically an extremely bright and short-lived star named WR124, or simply Wolf-Rayet. This star sits about 28,000 light-years from Earth, and it's about to collapse into a black hole. Yeah, its very hot core will explode into a bright supernova and give life to a shiny new black hole. Now, of course, I don't recommend going too close to a dying star, but if you did get in proximity to Wolf-Rayet, it's not going to sound like that. Scientists created this sound based on the data they collected about the star. They took X-ray data from Chandra, infrared imagery from the James Webb Telescope, Herschel, Spitzer, and WISE, and translated it into this beautiful musical piece. Astronomers call this process sonification. Well, everyone calls this process sonification, but this time it's astronomers doing it. They represented WR124's hot core with an intense, descending, scream-like tone, which personally I find very fitting. Then they added flutes to represent the nebula gases, bells for the stars in the background, and harp notes for the X-ray sources. String chords represent gases expanding into space, and there you have it, the sound of a dying star, about to become a black hole. But not every cosmic melody is born from death. Some are a little stranger, like the sound of this singing comet. Yeah, even comets can produce spooky sounds in space. In 2014, the European Space Agency's Rosetta probe detected a mysterious song coming from Comet 67P. Rosetta's instruments picked up vibrations in the comet's magnetic field, and this is what they heard. These plasma waves have very low frequencies, around 40 millihertz. Now, your ears can't hear a frequency that low, so scientists cranked up the volume on this comet. So now you can hear the eerie, whistle-like song of 67P, singing comet. Yeah, well, not all space soundtracks are pretty. Just like the soundtrack of Moulin Rouge, most of them are unnerving. Here, let me play you the sound of interstellar space. Yeah, scary, isn't it? This is the sound that we captured outside of our solar system. In August of 1977, a human-made probe, Voyager 2, left Earth and began its journey across the solar system. A couple weeks later, it was followed by Voyager 1. Now, if you're wondering why Voyager 2 started its journey before Voyager 1, well, just know this. Voyager 1 had a shorter trajectory and actually reached Jupiter and Saturn before Voyager 2 did. Anyway, both of these probes captured plasma wave audio recordings as they passed the planets in our cosmic neighborhood. And let me tell you, our solar system sounds unnerving. Here's the sound of Jupiter. Fair warning, it's not the most pleasant of noises. Yeah, if Jupiter was in a band, it'd make your ears bleed. This sound was recorded when Voyager 1 approached the planet and crossed Jupiter's bow shock. That's the boundary between the solar wind and Jupiter's magnetic field. Jupiter's magnetosphere is enormous and intense. This screechy, high-pitched sound is intense plasma wave activity from Jupiter's magnetic field and radiation belts. Coming up, we'll play you what Earth sounds like. It's pretty intense, but first, let's see if Uranus sounds any better. What you're hearing now is the sound of dust impacts on Uranus's rings. And this is the music of the Uranian magnetosphere. And this alien noise is Uranus's plasma waves. All these sounds were recorded by Voyager 2 as it did its flyby around Uranus. While this was happening in 2012 and 2013, Voyager 1 left the solar system and became the first human-made object to enter interstellar space. That's when it recorded this unsettling sound. I don't know about you, but to me, interstellar space sounds super spooky. It didn't stop there. No, Voyager 2 went deeper into space. There, it encountered not one, but 3 cosmic tsunami waves. These tsunami waves aren't like tsunamis we have on Earth. These are large-scale ripples in the plasma of space caused by massive solar eruptions. This sound was recorded when coronal mass ejections from the sun slammed into the plasma beyond our solar system. The sun triggered shock waves that caused interstellar gas to vibrate, and then Voyager's plasma wave sensors detected those vibrations. Now, Voyager 1 and Voyager 2 weren't the only crafts recording plasma waves that scientists would later translate into music, if you can call that music. In 2001, Cassini went on a mission to explore Saturn, and on its way there, this is how it captured Jupiter. Still a little eerie, but not as dramatic as the sound of Jupiter's magnetosphere. I will not play that one for you again. But I will play the sounds of Jupiter's moon, Europa. Space may not have the matter to carry sound waves, but it is full of plasma. The space plasma is charged particles that can vibrate and create electromagnetic waves. The sound of Europa you just listened to is the converted plasma wave vibrations that another spacecraft, Juno, picked up when it came close to this moon. To create these cosmic melodies, scientists look at the frequency of vibrations recorded by probes like Juno. If those frequencies fall near the range that human ears can hear, then they can play them back directly as sound. But if the waves are too low or too high, NASA speeds them up or shifts the pitch into the audible range. That's how we get a lot of these space sounds. Now, NASA's Cassini spacecraft didn't just record Jupiter. This craft orbited Saturn, and it carried a radio and plasma wave science instrument, an RPWS. And with that instrument, Cassini discovered that Saturn emits intense radio waves tied to its auroras. To create this audio, Cassini's team compressed 27 minutes of data into 73 seconds. Because the original frequencies were well above the human hearing range, they shifted the pitch so that you could hear Saturn's roar. Now, this scary noise scientists picked up when the Cassini spacecraft crossed the gap between Saturn and its rings in April of 2017. What you're hearing is ring particles striking the probe. Now, this next creepy soundtrack from space isn't from some alien planet. It's actually the sound of Earth's very own magnetic field. If you've ever wondered what Earth sounds like, well, thanks to the European Space Agency's swarm satellites, now you know. It sounds terrifying. To make this recording, scientists took real magnetic data from deep inside Earth's core and its space environment, then turned it into sound you can hear. Yeah, those low rumbles, creaking metal, and eerie whispers, that's the sound of our own home planet. The most intense parts of this track are based on a real geomagnetic storm triggered by a solar flare back in 2011. That creepy moan you hear is the sun slamming charged particles into our planet's magnetic field. A lot of these sounds are scary. Far and deep into outer space, you could hear two black holes colliding. What you're hearing here are gravitational waves that scientists converted into sounds you can hear. When black holes collide, they cause enormous gravitational waves that create ripples in space-time itself. These specific waves are called GW150914. They were created by two black holes, 36 and 29 times the mass of our Sun. When these two monstrosities merged, they created a larger black hole that was as massive as 62 suns. These waves happened over 1 billion light years away from us, and they were picked up by the LIGO Observatory. You could say that this is the sound of gravity itself. Space is vast and empty, but it's not as empty as you might think. Some regions of space have a lot of hot gas, and I'm not just talking about the region of space here in my studio, if you know what I mean. Anyway, hot gas can actually carry sound. Now, let's go back to our supermassive black hole in the Perseus galaxy cluster. What you're hearing is the black hole shooting pressure waves into the surrounding hot gas. Scientists detected these signals from X-ray data, and these are the actual sounds coming from this black hole. I mean, really, these sound waves are about 57 octaves below what you can physically hear, so NASA cranked up this black hole's groans into something your ears can register. Well, some black holes sound prettier than that. Remember the first ever image of a black hole? Yeah, this one. This is the silhouette of the supermassive black hole M87 star. This gigantic cosmo monster is devouring matter about 55 million light years from Earth, at the center of galaxy Messier 87. Now, of course, we didn't just take a photo of the black hole. This image was created by combining data from 8 radio observatories. In April of 2017, scientists linked 8 radio telescopes from around the world to form the Event Horizon Telescope. These telescopes observed a supermassive black hole, M87 star, and recorded mountains of radio wave data. From there, supercomputers stitched the data together, pixel by pixel, to reveal that glowing orange ring. Then, scientists took it a step further and translated the data into this cosmic song. Remember the Voyager 2 spacecraft? Well, one day it will reach the deepest depths of interstellar space and record the sound of a black hole up close. It's always better to send space probes into space, because if you came dangerously close to a black hole, even for a nanosecond, you'd be spaghettified, turned into human spaghetti. But that's a story for another What If.